All right. So if you were stuck on any of the questions from 12.4, please be sure to nominate them in the form that's attached to that lesson. And we're going to get started looking at inverse functions in 12.5. So get yourself ready for notes and we're going to get started. Now, if you remember some things about inverse functions, one of the most important ideas of inverse functions is that they cancel each other out. And this idea is exemplified by the identity function. So the identity function means given a set, let's just say A, the identity function of A is a function from A to A where the function of x is always equal to x for all x in A. So this is, if you remember, the vital idea of a inverse is that they give us this identity function that when you plug one into the other, it cancels out. So an inverse function, the way that we would define it is if f is a function from A to B, then f inverse is a function from B to A, where if f of A is equal to B, then f inverse of B is equal to A. If you remember, the idea with inverse functions is that they have to be one-to-one, and they have to, what that means is that they must be injective, because that's what one-to-one means, and it also must be surjective, because then all of B is used. If B isn't equal to the range, then it can't be the domain here. So f must be bijective in order to have an inverse function. It might have an inverse relation, but it won't have an inverse function. So given here functions f and g below, we have our function f and we have our function g. Explain why g inverse exists, but f inverse does not. And if you look at f versus g, here is where our bijectivity fails. So f inverse of b would be equal to both 1 and to 3, which means that it is not a function. It's not a function. Now, again, it might be a relation, and it is, but it's not a function. Now, G inverse, when we're given diagrams like this, I find it easiest to just write as a set of ordered points. So the first ordered point in G is from 1 to B. So that means G inverse is from B to 1. The next point is from 2 to C. So that would be C2 for the inverse. And lastly, from 3 to A, so A3 is in G inverse. 2. Let f be a function from A to B. Then f is bijective if and only if the inverse relation is a function. So what we've already said is that they have to be it has to be bijective in order to have an inverse function. Now, what we want to do is make sure we go backwards. So we're proving an if and only if. So the idea is that if f inverse is a function, how do we prove that it's bijective? If f inverse is a function from B to A, then f inverse of B is equal to A exists for all B in B. So therefore, f of A equals B exists for all B in B. So that means that it must be surjective. Right. And then, so that proves surjectivity. If we want to prove injectivity, what that means is what we just illustrated in number 1A, is that if it's not injective, then it would not be, then F inverse would not be a function, and you can prove this either by proving the contrapositive or by contradiction. I'm going to use contradiction. So say F is not injective. So F of A equals F of B. I'm going to use subscripts actually so that we can have our A and B separate. And A1 is not equal to A2. So I'm going to say that those are both equal to B. So F inverse of B is then equal to A1, and F inverse of B is equal to A2, which breaks then would mean F inverse isn't a function, but that's our contradiction. So therefore, it must be injective. Given the function f between r minus 2 to r minus 5, where f of x is equal to 5x plus 1 over x minus 2 is bijective, so we don't need to worry about proving that it's a bijective function, find f inverse. So if we know that it's bijective, we know that f inverse exists. That's what this tells us. We know that the function exists that we're looking for exists, so we just want to find it. This will be the same as what you've always done for finding inverses, which is just switching x and y and solving for y. So in this case, we'll say x is equal to 5y plus 1 over y minus 2. In this case, I would multiply y minus 2 over and distribute. So xy minus 2x is equal to 5y plus 1. We want to get our y terms on the same side. So I would subtract away 5y and add 2x. So xy minus 5y is equal to 2x plus 1. Factor the y out. So going up here, y times x minus 5 is equal to 2x plus 1. Solve for y gives us our inverse function, so f inverse of x is equal to, 2x plus 1 over x minus 5, which is why we have that as our codomain there, so that it can have surjectivity. If you're confused about anything that you see here, please let me know. Again, I will be checking my email through the end of this week, even though you don't have any new assignments. It might take me a little bit longer than usual to get back to you, but I will do it within 24 hours. Talk to you later.